Hi, hello, good afternoon. So this is the second part of our RenoZEB training. I hope you all had a good lunch break. And now we will start with Alessandro Pracucci. I'm sorry, Alessandro. Alessandro?
Good morning, all.
Good morning.
Larissa, I cannot change the slide. And okay, now it works.
Yes?
Perfect.
Okay.
Okay. Good morning, all. After this morning presentation of the RenoZEB methodology, this afternoon I'm gonna present you more in detail the products that enable the retrofitting for the building envelope itself. This presentation will be developed in different parts. The definition of the boundary conditions, so with identification of the technologies, the limitation dependent on the building envelope of the existing building, and the module prefabrication issue. And then we'll move on the presentation of the Focchi facade system has been defined with different solutions. A couple of design has been evaluated and gonna present you during this presentation. Then I'll move to the final design. That will be the one objected to the installation in our demonstration. And there's been also the prototype tested in the different activities for validation conducted until this moment. And finally, I show you the results of all this activity, and I collect some conclusions for your use. Let's start with the boundary condition about the existing envelope. The idea of Focchi facade is to provide prefabricated facade module for the deep retrofitting. The starting point was the concept to include different technologies. We mean sensors, actuators, shadings, windows, insulation, and other technologies in a single facade solution to be integrated, to be supplied easily and installed on site. And then there is the building application of these technologies. The first moment of the definition of these technologies has been referred to what should we include in these facade solutions. On the market, there are many different technologies. It's quite difficult to understand what is the best one for the different purposes. The general idea to have and to design a product able to be differently applied in different market scenarios has been as issued this type of matrix for the evaluation of the products that we have included in the facade. We have considered the different products in the columns, and in the rows we have highlighted the elements behind the RenoZEB. As mentioned during this morning presentation, the focus is to have deep retrofitting fabricated solution with low intrusiveness, with a high degree of neutralization based on market products. The utilization of this matrix has been useful to address the further phase. So we have classified all the different technologies that we expected to include and integrate in the facade module, and we have applied this matrix for all technology for prefabricated windows, module, and roller shutter, as well as a multifunction insulation board. The result here presented can show you that the table has given us an evaluation of the point of the product in line with the project expectation itself. In green, you can see what are the solutions that seem to be more valuable to be applied in a single facade solution. This matrix has been the base of the analysis and has been applied for all the products for the facade. windows and roller shutter, multi-factor insulation board, as well as a ventilation device. In this case, different solutions have been considered. For example, ventilation within the monoblock, or standalone system, or a centralized ventilation. But also for BIPV, for facade, we have included this consideration. Let's say that this matrix has been useful not for a quantitative validation of the technologies, but for a qualitative assessment. Thanks to this process, we have defined what type of technology would fit better with our expectation. And so for building integrated solar thermal and mixed solution. This is the final result of this first moment. So the identification of technologies can be resumed in this table, where you see the main components we define to be integrated in facade. So there is a monoblock for the windows, able to install different typologies of window independent of finishing of the window frame, independent of the glass typology, so able to meet different climate condition expectation with a single frame solution, able to integrate everything. Let's say that, generally speaking, this monoblock is used commonly on retrofitting of existing building to replace, to improve the thermal performance of the openings. In this case, we have decided to include this as a valuable solution inside something new that is the facade system. Then we have moved on multi-factor insulation board. So this is a solution able to bring air and ventilation throughout the buildings, entering in specific indoor environment. And the main technologies defined was to adopt a decentralized solution, so to maximize performances and comfort achievable. The ventilation devices is included in the insulation layer itself, so within this multi-factor insulation board. And then different BIPV have been analyzed, and the crystalline seem to be the most effective. We know that facade decrease the performance of photovoltaic because the vertical position is not the most efficient one, but crystalline can better manage this aspect. For what concerns the solar thermal collector, we have supposed to use solar thermal with air. And then the last part, you can see the integration of controller for roller shutters included, and the sensors that we have applied in the facade. These two last components are crucial to guarantee to the building envelope to be adaptive under a certain point of view. So to adapt the solar radiation and the lighting of the indoor space on the base of external condition. And the final element has been is related to the fixing mechanism of the facade on the existing building. On the market, it was not so easy to find something for the type of product we had in mind, so we have defined something specifically, and I'm going to show you later. First question I'd like to propose to you. Referring to the building envelope, working on the retrofitting of building envelope, what are the pitfalls you think are the most critical for the renovation itself? Now on Slido, you can put your word, and here you can see the word cloud. Okay, for someone else, but let's say that from, okay, Okay, good to know that quality is one of the main issues. Let's say that is one of the purpose of RenoZEB to maximize the off-site production, to improve the quality of the final product, and to minimize all the on-site activities. All the other aspects, as for example, openings, that is obviously a limitation. I'm going to show you what are the aspects considered. The aesthetics, another point I'm going to present you in a while, and thermal bridge, humidity, as well as air tightness is something that we manage. So I think that you can find something useful in the next slide. Okay. Time. There's double time. Yes, let's say that with RenoZEB, reduce the time on site is the key element we want to introduce, because we know that on-site activities are cost expensive, and the cost is also a matter of time. So absolutely, you see the final solution. Okay, increase thickness of envelope for sure. Okay, now I move on the next slide. Okay, we've started our consideration about building envelope limitation, considering the two demonstrator buildings we had within the project. There are two different buildings, one in Spain, one in Estonia, and as you can see, they are quite common considering a general building stock we have in Europe. The first phase has been to define for this type of buildings what are the limitations. So on the graphics on your right, you can see the elements that need to be considered for the realization of this RenoZEB facade. First of all, the limitation of structural component as slabs, as well as windows openings, which represent a limitation. Consider that we do not want to have an intrusive solution. We cannot change this aspect, because change this component would mean to introduce a discomfort for the user inside the building. It means often to move people somewhere else, and we want to avoid this aspect. Obviously, these conditions define differently the design we can achieve with the RenoZEB panel. In particular, the openings represent a limitation for our modules, and we have considered this limitation as the starting point to define the RenoZEB facade solution. In the detailed design, I'm going to show you in some slides in a while, we have started the design for the demo buildings considering the openings, because openings cannot be changed. We need to use the existing openings to size the new facade module. And after the definition of these modules, we can move on other type of units, including solar collector, photovoltaic, thermal, and so on, so to have finally a configuration for the new buildings. The result is a catalog of solutions. We have thought about something that could be could exploit a common frame based in particular on aluminum frame with an high standard of quality, especially to achieve air tightness and to avoid water penetration with gasket and so on. And on this frame, we have thought about to include insulation, so to improve the thermal performance of the building, and then an external finishing. This external finishing can be changed in relation to specific aesthetic request of the architect, as well as a cost issue or other element. Here you can see a sort of catalog of opportunities deployed by RenoZEB facade. So same base, same frame, and different external finishing. And this being the core of our design phase. Let's go deep inside what we have designed. This is the overall concept. So we have decided to not touch the existing wall. So the existing building envelope would remain the same, and we with the purpose to exploit its performance to improve additionally the retrofitting scenario itself. In brown, you can see the RenoZEB prefabricated panel. That is the core of this solution that is installed on existing wall, exploiting a cavity where we can position, first of all, the brackets, useful to hang the prefabricated panel, as well as to install additional insulation, mineral wool, and so on, to achieve nearly the energy standard and very high thermal transmittance. Here, you can see a first step of layer definition. We have started considering the traditional curtain wall facade scenario, so using some steel, some metal sheets to close the units in the rear as well as in the front, some mineral fiber inside to improve the performance, and then we have supposed an external finishing. In this case was a plasterboard with a membrane, so a very low-cost solution. That is something we have started with. The design. Two steps have defined the design. The first moment, as I mentioned, we started considering the traditional way to design the facade system for curtain wall solution. In particular, we have focused on the purpose to meet the standard defined by facade certification with EN 13830. And with this purpose, we have started where we know better the performance we would have achieved. So in this solution, the layers we have is based on an aluminum profile, where the two mullions are joined by the transom, and the frame is closed by a rear metal sheet with bubble barrier, obviously, but also in the front we have another metal sheet, and this is the first solution. This is a 1.1 solution because in the first design we wanted to we had expected to use mechanical restraint for the external finishing, so to reduce the utilization of sealant and not mechanical application. Since this phase, we had thought to use different finishings for our facade, like fiber cement, porcelain tile, glass, wood, or other solution as a plasterboard. Aquapanel is one of the commercial products we have tested. Obviously, in some case, the introduction of membrane to improve the characteristic of the external finish was needed. In this case, for wood and plasterboard was needed a membrane for the water resistant issue that was not guaranteed by this type of product. This solution has been increased removing the mechanical restraint, but adopting an angular fixing for the external finishing. In this way, we have completely delayed the frame all around the unit and having something more similar to a ventilated facade. It was something requested by architects we involved in the very first phase, as well as by some preliminary assessment with the demo partners we have involved. The finishings are more or less the same. Obviously, in this case, the utilization of the membrane is suggested. During the validation of this component, of this product, we have done different analysis related to the thermal performance, and we were in line with the expected result of the product, but also for internal condensation. Let's say that by the norms, we were perfectly online because the condensation we had during cold months were completely absorbed during the hot months. And this was valuable both for Durango, so the Spanish demo case, as well as for Voru, where obviously the winter time is longer, the cold months higher, and so the condensation was more intensive. However, this design one solution for Focchi facade was perfectly in line by the north. Let's say that speaking with demo partners, this solution was adoptable for sure, but they would have preferred to have something different without condensation risk. So we have designed a second solution for this Focchi facade, eliminating, deleting, and replacing the metal sheet with a membrane. We have adopted market membrane with wind load resistance, with high breathability, also in the rear of the panel. In this way, we have changed a little bit in relation to the common way to design the curtain wall, but introduced this membrane, we have been able to, first of all, be in line with the final design expected by the project. So the external finishing remained the same. In this case, with a mechanical strain, or in the case of the angular to fixed external finishings. But the result was to eliminate completely in both the two demos and the two climate conditions, both in Durango in Spain and in Voru in Estonia, the condensation within the panel. This was considered very well by the demo partners, because we had a breathable facade, guaranteeing that also during the installation phase we could not have problem due to rainy time or humidity inside the existing building, because this renovated panel could allow to have a breathable solution to be applied without any problem. This is the case Durango. As you can see, there are no problem of condensation, and this is for Voru. For Voru, this one. Okay, does not move. Okay, it is for Voru in Estonia. So different climate condition, very different. Could find in this facade a solution. Let's consider that Durango is in Basque Country, with a high level of humidity and with a temperature not so low. In Voru, it's very different. The condition where there is a low humidity, but also very low temperature. So in different conditions, we have demonstrated that with these facade, we could meet both standards requested by the project. Obviously, this change between the metal sheet utilization and the membrane in the rear of the panel open a question: could we be able to achieve the curtain wall standard normalized by EN 13830? This was a question. We put it on the table, and in the test we have conducted in a second moment, we have better defined, understood if this was achievable or not. And this is the final solution. So this is the solution we have designed, and the one we have tested and adopted for the building is the solution 2.2, considering the previous slide, and where we have the existing wall, a bracket design for the installation of the units, and position inside the cavity. Let's say that this cavity does not represent a problem for propagation. We have two reasons for this aspect. First of all, if I want to use this cavity to have an additional layer of insulation, this layer would be completely full of mineral wool, and so I am not air with that can cause me propagation of fire. In the case it's not necessary to use this cavity to fulfill to be fulfilled with insulation, because the overall thermal transmittance of the new building envelope is enough for the norms or for the performance to be achieved. I can consider for as fire stop barrier front as a front slab solution where positioning specific mineral wool. In this case, it's quite common in mineral wool. We can stop fire propagation and have a compartmentation for the cavity itself. And here, now I'm going to show you the 4 unit typologies we have defined. There are 4, but with different possibilities because they can be customized. First of all, the opaque unit. It's a unit prefabricated off-site with a dimension maximum of 1.2 meter for 3 meter. This dimension is dependent on the utilization of on-market external finishing as fiber cement or porcelain tile that are already industrialized. Obviously, we can imagine to have something also bigger, but then a different solution need to be imagined for the application of the external finishing. This facade has been designed to be completely opaque to guarantee to cover those parts of the building which have not any relevance for openings or for other system to be included. It's based on an aluminum structure, and external finishes can be different solution like fiber cement, as well as composite wood panel or porcelain tile. Let's say that we have validated this solution for very different type of materials. Our main purpose was to use something that was on the market. So aesthetic reasons or budget of the building can find different solution using the same type of product. And here in the different finishing, you know quite well what are the costs of the materials, and so also the overall cost of the panel can change. Then another unit is the window unit. This unit has been designed to fill the openings and to replace the existing windows with a new windows. Behind the application of this facade, there is in the first step to install the unit, then remove the existing window, and then position on site an introdos for the finishings. This unit is as a monoblock, which includes the roller shutter for blinds and shading issue, as well as can be also integrated with the ventilation within the monoblock. The result achieved by this unit, it's a thermal transmittance for the unit is 0.66 for Durango, while the request was 1, so much more better than what was requested by the norm. And for Volu in Estonia, the result was 0.47 watt for square meter Kelvin, while the request was 63. I get back on the opaque slide just to show you the result for the opaque unit, where you can see that this is the transmittance 0.28 requested by Spanish norm in Basque Country. We achieved with the solution, considering obviously not only the panel, but also the insulation in the cavity, as well as the existing wall in this specific demo. We achieved this solution, so perfectly in line with the expectation of the project. And in Estonia, the request was to achieve 0.13 watt square meter, and we were just a bit lower, but lower. Coming back to the Windows unit, this is the monoblock. The monoblock is a pattern product provided by Beckno. in this case, that was adapted to the specific request of the integration in the unit and also to specific request of demo buildings. And it can be inspected, the roller shutter included from the inside without a maintenance from the outside, so allowing to have something very easy to be also maintained during time. This roller shutter, that, to give you an example, can be in different material, aluminum as well as also PVC. This is the unit, the window unit, that include also the sensors and the actuations of the on the roller shutters. We have included some IoT components in this facade, in particular installing a sensor on the outside that can be useful to can be used to understand the environmental condition and to adopt actuations for the roller shutter. The idea behind this facade is to guarantee an high control of the roller shutters and improve the comfort, the lighting comfort, as well also the heating gain during the different moment of the days. These are further improvement for the existing building, because nowadays there are very few cases where it's possible to introduce this type of solutions, and we rent the facade. We could also include this type of product in a single component. And then we move to 2 units with energy generation solution. In this case, we have a solar collector unit where we install a solar collector on market on the facade. We have validated this solution with the connection with the pipes that are on the cavity and need to be positioned before the position of the facade itself. And similar is the photovoltaic unit, where we produce electricity by using photovoltaic itself. Here, the first prototype. These are very first prototype manufactured in 3 years ago, more or less, 1 year and a half. And here you can see the aluminum frame we've used, the transoms adopted for mechanical reason, the insulation and the membranes. Here, the external finishing. Here are some validation for the monoblock, where we have position additional elements to have a solution of the monoblock closer to the existing building and avoid to have much more distance for the user to open the window itself. And here some solar collector solution. I'd like to push now on this aspect of this type of facade, because we have the chance to adopt an initial element. Okay, we have the possibility to adopt an initial element to be fixed on a unit, also low cost or with external finishing we now appreciate, but then being a mechanical solution with this type of fixing element, we can replace it in case of damages, obsolete, but also in the case I want to change the aesthetic of the buildings or to improve it with some new energy generation solution of photovoltaic solar collector. This is quite valuable, consider that in this way we can improve the energy performance of the building with a solution, and then if you want to change during the time because the tenant changed, because I want to change the rent of the apartment and so on, I can change the finishings itself. Okay, yes, on phase during the prototype inspection, our team working on the different solution. And here the unit. The unit you see in design here have been assembled, and you can see the different finishings adopted. On the left, you see a unit with wood and composite solution. In the middle, there is a porcelain tile finishing, and on the right, there is a windows unit with a fiber cement. And here, the unit with photovoltaic and solar collector. This is installation. Just to give you a first overview of the installation issue, we have simulated in this phase an existing building and tried to position the bracket to hang the unit, and we start the installation of the unit itself. And this is the final result achieved. So in this case, you see obviously a patchwork of different materials. That is not the purpose of the utilization of this type of product, but you can see the different opportunities we open with this solution. External finishings are possibilities, but we have focused also on these elements because the nearly the standard need to improve the thermal performance in the first moment of the building. And here you can see the existing envelope has been produced here, the cavity where we position mineral wool and the panel. Here the introdos. The introdos remains the only, the new introdos, the only activities to be conducted on site after the installation of the facade. Okay, here you have an idea of the RenoZEB solution. Do you think something is missing? Some further implementation you suggest about finishings or technologies to be included in further steps? Cannot see no answer. So, oh, everything is perfect. Or everything, okay. Biosource material, okay. Okay, I can start answering to this element. It's possible to use, obviously, biomaterial because it's not specific on specific materials. The insulation, in this case, mineral wool, but we can replace it with wood fiber as well as other biomaterial. Let's say that wooden frame is also another opportunity for the frame. We are working on it in a parallel project. The aluminum now represent a high standard of quality, especially for the time of production. We can have a lot of kilometers of aluminum profiles in a few time, and aluminum remains material recyclable, fully recyclable. About fire compartmentation, I introduced the topic during the presentation. The compartmentation is not a problem because in the case of the cavity is completely full of mineral wool, and so there is no need of additional compartmentation because there's no air where the flames can go through, and the mineral wool is class A material, so without any particular problem. In the case the cavity is not used for the for additional insulation, we can position specific mineral wool as a fire stop in the front of the slab. Between the chains of the unit. Usually that is the position where we install the compartmentation. About thermal bridge, we have a profile with a polyamide profile in aluminum, so we reduce the thermal bridge, and we have no particular problem about this point of view. Obviously, aluminum has not great thermal performances, but it's quite consolidated technology to be used with polyamide to reduce thermal bridge. Yes, this is something we are working on about life cycle assessment and circular economy. It's something that we know that is in the strategies of the European community, and so it's something we need to consider. Breathability of different build-ups. What do you mean with build-ups? If you want to put on your microphone. Okay, however, let's consider that the utilization of the membrane guarantees a full breathability of the solution. And in the test that we conducted, we demonstrate also, yes, let's say that we have a membrane on the inside layer that is a vapor barrier, but guarantee the breathability on the other side because there are different type of membrane on the two sides. We have two membranes on the front side where we have breathability and without problem for example, UV protection. On the other side, we have something that is a vapor barrier but guarantee the breathability from the outside to the inside. So if from the inside to the outside we have a vapor barrier, from the outside to the inside we have high breathability, and this something for us valuable for the type of product. Okay, I move on. Okay, here the test results of the facade. We had some activities to be performed to validate the solution. First of all, the thermal performance. In addition to the simulation that I've shown you in the previous slide, there are also specific activities conducted in Cubic, test building in the Rio, in Tecnalia facility. And also for heat breach and condensation risk, we have simulated, but as well as we have tested ongoing in this last month in Cubic. For what concerns the other test, we had three different typologies of test: an acoustic mockup, useful to validate the insulation achievable by the facade; the performance mockup, so to test the water tightness, the air tightness, the wind load resistance, and the impact of the facade, and this is normalized by the EN 13830. And then there is the fire mockup to understand the reaction to fire classification achievable at this moment from this type of product. And then there is the fire resistant. We have not applied it because a ventilated facade was not applicable. Let's speak about the acoustic mockup. We have decided to test the facade to understand the performances. The norms are the one reported here, and we have not focused on the flanking test because the existing envelope is responsible for the flanking between the two floors of the building or the department on the same floor, not the new building, not the new facade that is connected only through a bracket with the existing building. So we only consider in-out test for insulation. We have here in Focchi, in our premises, test chamber for this type of test, and this is the test we have designed for this particular validation. Considering that RenoZEB is not applied as a single panel, it could be obsolete, but it's not applied only. We wanted to understand what are the insulation considering an existing wall. And we have tested one brick wall just to know what was the insulation. One brick, only to have a reference. Obviously, there are no one brick wall almost anywhere, but we want to have some benchmark for the implementation of RenoZEB. And then we have installed the RenoZEB panel to see the differences. Here's the test. In our acoustic chamber, we had tested three different configurations. The first is the existing building envelope. So only one brick wall with the results achieved, just to know what are now the building reference we want to move on for the insulation point of view. The second configuration is the existing building envelope plus the new RenoZEB curtain wall solution. and in this way we have tested the overall performance of the facade. And then we wanted to also understand what was the delta of the performance without a window, because the initial one brick wall was not with a window, because having a window means to have another product, another technology with some glass different to be defined in a unique way. So we have tested in this configuration wall one brick wall only as a brick without any opening. But in the second configuration we had an opening. So in the last configuration we closed the window, and we just to know exactly what are the differences. And here are the results. So in the first configuration, so the existing structure, the current insulation is 46. Considering the RenoZEB introduction, but also an opening that is an issue for insulation purpose, we achieved a similar insulation, but the main result is the one of configuration 3. So considering no openings in the windows, we could effectively improve with the RenoZEB panel the insulation of the overall system. After this acoustic test, we start working on performance test. In this case, we know very well this type of test. We conduct performance mock-up in each of our project, because we design project each time different, and so we are quite confident about the result. It was not the case of RenoZEB, because we had something quite new, especially for the introduction of this membrane that is not common on our market. So we had to think if everything was okay, and this was the real challenge of the new envelope. In this case, we have not adopted an existing wall as a reference, but we have pushed additionally to know if you could achieve the norm standard without the existing building envelope. And this was the reason, because we don't know the architectness of existing building. We think that there could be many different possibilities. So our aim, very challenging, was to work as we had only the other end of the panel to achieve all the standard expected. Obviously, in the real case, with an additional layer of the existing wall, the result is also in line, and we can achieve also better performance. But achieving the norm reference to receive the certification only with the panel was something for us very important, just to understand if the design was correct or no. This is the test. Here you can see the units we have tested with 2 external finishings, the one that we are going to adopt in the demo buildings with fiber cement and porcelain tile, and a window unit. Here the test, just to give you an idea, we speak about air permeability, about water tenderness, impact with different type of the element to be used, as well as also the deflection gauge. Here the test. In this test facility we have installed the facade, and the results are quite interesting. Here you can see the pressure depression test, because this is a test we commonly, also in this case, we have pressure of plus 600 Pascal and the depression of minus 600 Pascal. So we need to test both the pressure and the pressure and see how it works. If there is some rain entering, water and air loss. The impact resistance test. Here you can see 2 different cases with different type of elements on the external finishing, but also on the window itself. Okay, here all image of impact tests that are perfectly in line with the expectation. And here, I don't know how much you are confident with this type of test. Just to give you an overview of the type of test. So the norms expect to have different tests in different position with different kilograms to validate all the system. Here the result. We are very proud about these results because we achieved our expectations perfectly, and we have designed and manufactured a product innovative for the carton board market, where no more metal sheet but membrane could be used. So the results are perfectly in line and allow us to have the certification for the product. The last test is the thermocap test. This is not a test mandatory for the certification at this moment for carton wall facade, but we wanted to understand the possible classification at reaction to fire of the facade, and so we tested the facade with the SBI test. So it's a small chamber of 1 meter for 1.5, where the heating of during combustion and the elements are analyzed to see the possible classification of the component. The idea was to have a preliminary assessment of the renovated facade for the different in the different side. This test needs to be conducted where there is air. In our product, we have air from the inside of the building, from the outside. In this case, not to be considered, obviously, because we have not an existing facade to be tested. Could be considered from the cavity to the inside, but also in this case, we would have not tested the renovated facade. The 3 cases we have tested are from the cavity to the renovated facade, from the outside to the renovated facade, and in the ventilation between the external finishing and the insulation layer, let's say. Here's the design with the 3 different tests conducted. Here, the test itself. So all the tests will be conducted by a third entity to know effectively the result, and we have burned everything to see the result. Here you can see 2 images that anticipate the result. So we were not we were confident about what we were going to see. So where we have tested external finishing, there are more or less no change, no problem for reaction to fire. Indeed, we could achieve a potential classification of class B. Main problems are on where there is the membrane. These membrane are class E solution. Obviously, we have to find a compromise with different solution, but generally speaking, this is plastic, and burn the plastic means to have potential classification on C, very close to B1, and probably in next steps we're gonna make some change in the test design, because test design can be improved to achieve the B class, but these are the results. The main problem is related to not the external finishing. So the external finishing is normally classified reaction to fire, so we have no problems to achieve the type of classification, also integrating the external finishing on our facade. The problem is related to the membrane emission due to the fire and the overall temperature within the chamber, and also the polyamide melting, because polyamide is a thermal break for profile, but is also in this case can have an emission problem, and so it melted. This is a problem obviously of the material, but also of the design of the test, because the corner was not the real corner. So we have burned a solution that is not the real one, so we need to protect differently. We know it, and indeed in the building this problem has been solved. Another test of the facade is the one on cubic. This cubic is for, as I mentioned, for all the energy and thermal assessment of the renovated facade, but also for installation. We have tested both aspects, and it's been a first validation for the installation steps to be conducted also on site. You can find videos on our YouTube channel. The facade, the system facade, is being applied on the demo buildings. Here you can see the existing building as it is now, the design as expected by the architect responsible for the project, and how we detail design the project itself with specific units, specific dimension, specific code to identify unit for the building. This is the case of Durango, but the same also for Volo. In the next month, we are gonna have also the retrofitted buildings, so these images will be rich with the final result, and we could see the first aesthetic appealing of the building. Now, a question. What do you think is the most valuable result achieved by the test conducted? The acoustic test performance, the performance test, fire test, the installation validation, or none of these? And you suggest something different. Okay, good to know the installation is relevant for you, because let's say that we can achieve different performance, probably also fire test in different way, but with this type of module, the installation is much more faster. So it's one of the key elements with pushing, and I like you appreciate it. Now you see effectively on site also difficulties for this type of installation, but because consider the skirting wall is not a well validated technological system, but there are no so trained workmen for this type of installation. So also know if for people that have no expertise on this field can be something easy to be managed is another element to validate the solution itself. Okay, we can move to the conclusions. Before the conclusion, I'd like to ask you another thing. What do you think that after all these we have presented are the most interesting characteristics of the render facade? Okay, good to know that all different aspects are relevant for you. In particular, modularity and adaptability are important. Ready-made, I appreciate it because I'm a fan of prefabrication of site, so it's a good point. Quality assurance, for sure, with the off-site procedure to guarantee quality, we have higher final results of the product. And okay, thank you for your insight. Just to recap, the conclusions. With this solution, we have designed a plug-and-play facade with different technological solutions, integrated different products that now are provided by different supply in the value chain. So ethics, ventilation, windows, the IPV can find in RenoZEB panel a single solution to be to integrate all these aspects. It can be customized, and this is very relevant from our side because the market needs different type of solutions. So thermal performance or external finishing can be changed in line with architect expectation or cost issue. It's very high quality solution. Prefabrication guarantees a high standard of production. Let's say that is a mechanical product with a millimetrical precision, and so also the quality itself it's very relevant. Different integration, both from an aesthetical and functional point of view, is relevant for the facade to meet different expectation and to have that adaptability that you have underlined. And it's for sure the installation is quite easy because there are brackets and bolts and a module to be hanged on it, and so it's quite easy, but also time saving. The time of on-site activities reduce a lot with this type of product, and there involvement of different actors on site, and so everything can be easier to be managed. The system is low intrusive, so users of the building it's not necessary they are move out during renovation, and it's adaptable to different climate conditions. So you have seen two use cases in Spain and Estonia, and you have noted how the final thermal performance could be achieved without any particular problem. And finally, is very consistent with the current building envelope standard for counterwall facade solutions. So we have introduced in the retrofitting market a new type of product, more or less. Before answering to your question, that there are some questions on the chat. How do you evaluate this final RenoZEB solution? Okay, thank you. Thank you for the presentation. It means that we are walking the right way, not in the wrong one, but obviously there is something to improve. I answer to your question. I start with the texture to the finishes. Yes, obviously, each finishes can be customized. We have adopted metallic finishing, but nothing excludes to introduce texture on a glass or other component. Let's consider that each product that on the market can have a texture on a material can be applied more or less with the mechanical or structural silicone solution can be evaluated. About the shape of the unit, yes, it's possible to have different shapes. Obviously, there are some issues related to those boundary conditions I present in the first moment. So where the slab, because we need to connect obviously to the slab or to the load-bearing structure. We have to find in the market products that are with that specific shape, but it can be made obviously. The frame is rectangular for industrialization reason, and also to optimize the transport shipment on the basis of the shape you have in mind, but also the size. Also, the shipment can change, have different cost, extraordinary truck needed, and so on. So we need to we have tried to find out a solution to optimize all different aspects in this aspect. When I speak about performance of the performance test, it's not thermal performance. Thermal performance are validated in cubic, and it's an activity ongoing. When I speak about performance test, I speak about the EN 13830 norm. That is a norm, the standardized or the cart wall facade norms. And in particular, we speak about air tightness, water tightness, impact resistance, and with load resistance. This is the performance for cart wall facade. The tests are generally, they are conducted, this type of test is conducted in laboratory. They are independent of multi-story building. Indeed, this type of test allow to have the certification with the type of test that are 7 meters prototype and tested, also for allow to have the validation for high-rise building. So it's not a matter of stories, but it's the type of test we conduct during the performance test. But it's obviously considering. And the main issue, just to mention to you, because it's focus, we need to pay attention when to, in generally, retrofit the building, but also obviously use this type of product, is related to the load bearing structure of the building. This is a lightweight element we install on the existing building. So the load bearing capacity of the existing building need to be able to support also this lightweight component. And this is one element I'd like to catch your attention because it's very relevant. I think I've answered to all questions. I don't know if someone want to say something. Just switch on your microphone. I will be glad to answer directly to your question and to receive your feedback.
Yeah, this is Michele here. I have a comment to add according to the environmental impact of the project. It is one question that came up before. In the project, we have a task that is devoted to the life cycle assessment, and we are going to do the life cycle assessment of the Focchi facade, just for understanding which is the environmental benefit. We have also environmental impacts and results that we have to justify in terms of decreasing the waste during the retrofitting process. And so we have some issues, environmental issue to face, but for what has been mentioned related to the circular economy, I'm afraid to say that we haven't in this project, as we have in others, the circular economy philosophy to be demonstrated, because it's a wider and more holistic approach in a transversal platform to organize everything. So so far the project has this target, environmental one, and yeah, circular economy is far for us for demonstrating, but we are sure that at least for what we are going to validate, some aspect of the circularity will be also addressed, not all. Thank you.
So I guess we still have 15 minutes or slightly more, 20. If anyone has any comment, any feedback about the system and what we present, if anyone wants to speak, this is the opportunity.
Hello. I am curious if do you have any interaction with similar projects, either on the digitalization BIM side of your project, or in the side of the prefabricated renovation systems that that have been developed in these past years?
Yes, if you allow me, I can reply to this question. Yes, indeed, we have very close networks with our sister project, the project that are very similar to ours, that came from the same core. And so yes, we have this very strong network. In fact, we organize an event right now that is for the end of this month, from 28 to 30. That is a Sustainable Place 2020, where we are going to talk about how our projects are dealing with the renovation wave, for example, and other Green Deal issues. So yes, we are in contact. We know which is the status of each project. Each project has different peculiarities, and somehow we do a benchmark one of to the other to understand and also to improve our expectation and our activity in the project. Also, apart the sister project, we have also other contact with other outside projects that could be live, but also other Horizon 2020 in terms of also beams and twin building application as well. So yes, we do. Yeah, you can see in the link the sister project that Larissa has written in the chat. And yeah, the Sustainable Place, and we are also in contact with others as well by social media and also by emails. I've been invited in other projects in the past for introducing RenoZEB and interchange experience. So yes, we are very active in that, thanks to the dissemination leader that is Larissa, and the ACE, the organization in Brussels.
Hi, it's Judith here. Can you hear me?
Yes, hi, hello, Judith.
Hi. I'm sorry if my questions sound a little unaware. I just wondered, when I was looking at the website, the case study in Lithuania, is that the energy performance, is that the existing energy performance or the post retrofit energy performance?
I think that is the current
270 kilowatt hours per meter square per year.
I think it's the current one, because we are in the process of starting the renovation in the building. We have a simulation analysis about what should be in the future after the RenoZEB solution application. But yeah, we have still to demonstrate and validate them. So I'm sure that is the current one.
So
this
before
building,
the intervention, you mean?
Yes, it is. You just consider that this building is an old one, and is a private big residential building that we have visited with a centralized heat system is placed in the underfloor of the building, with ducts that go from the roof. So it's a very old one.
So what I was, and what sort of kilowatt hours per meter square per year do you think you can get the building down to?
Well, I don't remember the figure, but I remember that the energy category should be like B or C, if I don't mistake.
No, I'm not sure what that means in terms of kilowatt hours, because B and C is different in every country. But kilowatt hours are kilowatt hours ultimately. But I did wonder, I think what would be a really helpful way of showing these case studies is to show a before and after, a kilowatt hour per meter square per year before and after, and the energy bills before and after. And I also wondered whether you, I mean, I didn't quite understand how the retrofitting works. Do they procure directly with you, or does a contractor?
Yes.
How does it work?
Yeah, first of all, we are running for more than 1 year. The ex-ante analysis is the baseline. That is what is the analysis. We have monitored the building for more than 1 year, so we know all the kilowatt hour, outside temperature, humidity. We know all these figures as they have been for real. And so we are going to use them like baseline for the after renovation, in which we are going to do the same. And we, of course, we are going to do the delta, the difference between the ex ante and the post retrofitting, to demonstrate and validate. Okay, so that's for sure. We already had the methodology done. Everything. We are just waiting that the building is retrofitted. Second question is this project. Deliver funds for the retrofitting of the building, so they are going to use all the budget they have, but also they have applied for also a national funding because they need more money for trying to retrofit all the building, not only outside by the RenoZEB project, but also inside. Yeah. Anyway, we are not going. We don't know right now, because we have to talk about this next week. So the last news are the one I've told you. So in the first idea is that they are going to retrofit 100% of the building, and they are going. Yes, they have done a private procurement, and they already have a contractor that is going to start this week or next week. The retrofitting activity. So from Focchi, they are going to send the bracket and all the material. They are producing underway. So they are receiving these units, and they are going to install. Focchi is going to help them, the contractors and the guys in the field, doing that, because it's a new product, new technology. And that's how it's going to be done. Consider that in the case of Spain, we have a public building as a demo. So there is a little bit more complex, because there are public procurement, and we are having some issue right now, but some delay, but they are going to solve this delay. And mainly, we are going to talk about this next week as well, but they're going to start in short also the retrofitting of the building just outside.
But do I understand correctly that aside from the cube building, the other case, that there are no case studies of the product being applied yet, or am I wrong?
No, we have done a first test in the cubic building that is a testing laboratory, QRL6 in Tecnalia. So we had already first impression and solved the first practical problem of installing. And according to this first experience, we already know how to do that, avoiding any any problem during the installation in the real building. So this work has been done. Yes, and just we are waiting the starting of the activity in the demos right now.
Okay, and when do you think they'll be completed?
Yeah, we have discussed internally. According to some of the experience of them, they consider that they could take up to 3 months average. So it means that consider also that in Estonia the weather is a problem, because they are in rush, because they have to prevent the upcoming of the winter, because everything is frozen there. And so if they start now in October, I would say that the end of December, January should be done, but it depends. It depends from a lot of variables that we cannot control today.
But your aim is to have these prototype projects complete over the next 6 to 12 months and have these examples properly portrayed as a before and after prototype. Is that right?
Yes.
With all
Yes.
the relevant data. And do you think you will be up and running with, and so will you be available to do other projects beforehand, or is this ready for production? Have you got, or how does it work?
This is another question, very interesting for the exploitation, the industrial upscaling of the project. You just have to consider that this solution is a tier 7. Tier 7 is technology written as level 7. It means in European spell is that you have demonstrated your product, your innovation, your technology in a demonstrating environment. We have discussed internally that we may consider this also tier 8 because they are very close to the market. As you know, tier 9 is already the market. So it is a test. It is a real test, more real test. So for the exploitation point of view, we think that we can. They are on the market. They could be put in the market, but we need some other final owning test or owning experience in real demo. So if there are other projects that would use our solution for them to test and to also realize that it works, we would be very happy to support this. In fact, I'm also talking with other realities to see if it could happen outside the project budget and outside the project. But so far we haven't found any solution. I mean, if you consider your activity, your daily job, you would like to make some experiment, at least from the design point of view, using RenoZEB solution and see how they works in your real work. So for us, it would be also a very a good point. First of all, because we are using other testing opportunity, but also because we have also a point of view coming from the outside of the consortium that sometimes, or I would say always, it is very helpful. So it is also
what do you think the cost of the solution will be in terms of per square meter of facade or per ton of carbon saved?
Well, if you're talking about the real cost of production, we have prototype costs so far. The cost we have shouldn't be so, I don't know, supportive. We know this cost for per square meter, I think. Yes, and not per energy, efficiency or per CO2 saved or something like that.
So you don't have a ton of. I think it would be really helpful going forward to have a cost figure per ton of carbon saved, because that's how all of these measures are compared in terms of their viability.
Yeah, it is not that, Judith. Your name is Judith, right? It is very difficult to do this because it depends from which is the performance in each solution. So we cannot translate that in real figures, simulating. Well, we can simulate that, but it shouldn't be the real figure. So it is not the right or the ethic way of proceeding. Also because applying in different building, the response and the feedback is different, completely different. The same unit in different building would have a different behavior, maybe.
Okay, but so people will have to somehow find a way to understand the benefits, and there are other ways of framing it. You could say that you can bring any building down to passive house levels, for example, which I don't assume is the case, but yeah, so just trying to be helpful about how it might be possible.
We can reach these figures just after the validation. And after using, we can use this KPI for our prospection, economic prospection in the exploitation plan that we have at the end of the project month 48. And we have also another deliverable that is related to the industrialization, which Focchi is the leader, of course. And just to see, just to reply to this question, because so far we have a cost. So far we don't know how which is the real behavior in real life, and we don't know how to upscale it industrially, because when you upscale, the prices decrease. So so it is something that we have to do, and we have tasked for that toward the end of the project. So I'm sure that we will reply to you.
And do you think you're aiming to achieve a performance that would match passive house levels?
Well, I cannot say either yes or not now. I would like yes, but let's.
But is that something that you simulated and you're aiming for, or is it not?
Well, I don't remember the figure of simulation. That's the problem now. I don't remember. We have simulated in a big deliverable. I don't remember. I'm sorry, but
yeah, I think that would be quite an important figure to have up your sleeve.
Yeah, but for example, in terms of CO2 tons saved, in terms of near to zero energy building definition that I know that is changing in every country, it is not just the passive the passive way of increasing the thermal behavior, but also that the renewable energy technology you stick on it as well. So there are a lot of
no, I mean so a lot of that is counted before you put the renewable energy. So the heat demand is not meant to be more than, I think, somewhere between 10 to, someone else probably on the call can correct me, but somewhere between 10 to 30 kilowatt hours per meter square per year. I think the heat demand is meant to be under 10, if I'm correct, but I'm just thinking of it from the top of my head, which would be quite a big improvement, for example, the Lithuanian project. But yeah, so that there is a scale that people judge these things at, and it would be really helpful to see this to see the results communicated within that format.
Yeah, for sure we will consider this format, because they are put into the method we have already triggered for the baseline. So we have a lot of data collected and a lot of KPIs created accordingly. But we are in the process right now of waiting the retrofitting real process. Yes, at the end, this deliverable will be public, so you will be able to read them, and also if you have questions, we can reshape if there is something missing. We can, we can also consider you as stakeholders of the project, and during our last part of the project, we can also involve you in the final activity, into the communication activity, in which you will receive all this data and you can read, and if you have questions, you can get back to us.
I think from our perspective, it's more of a question of how little we have to read in order to make a judgment about whether this product is applicable to a design situation or not. Do you see what I mean? Architects, in the first instance, would want to see how applicable these products may be to a real life situation, and the things that you will be looking at it on a larger scale project. You will be talking with your investor about the ton of carbon saved, about the cost per ton of carbon saved. On smaller projects, probably cost per meter square, and I mean that's everywhere anyway. and then the level of thermal performance you can reach applying the product.
Yeah, we will have that figure for everybody, for sure, and we will have them once we have validated them. We don't want to just stick to the figure related to the simulation. We would like to validate them, and always consider that this is an innovation project. We are deliver a tier 7 product so far. You know, we are in the middle of something that is proxy to the market, but something maybe should be done to improve. And consider also that the unit could be customizable, customizing. I mean, in the sense that in the day of tomorrow we can improve also the catalog for customization of the unit as well. So for us right now is a test. We have used less material. We'll use it, you know, at least for the aesthetic point of view. But the day of tomorrow, I think there is a lot of potential exploiting these project results. But give us the time to validate them.
Yeah, but I think all I'm saying is that these are really basic indicators for the viability of the product. So it should be something that would that needs to be on the radar quite early on.
We have them, believe me. All these KPIs are in the
I'm
list.
sure you do. I'm sure you do. And the last question I had, sorry, I'm hogging the line really. If anyone else wants to have a go.
No, please. Go on.
I just wondered, are you envisaging this service to be offered together with the analysis service? So would you, as a subcontractor, undertake the point cloud survey, the analysis, the work with a designer, or design offer the solution yourselves, or how do you envisage this?
Yeah, this is a discussion that we have in the exploitation part that has to be finalized with the final agreement. It is something that we are discussing with the industry of the project to see which is the best pack of service we can offer, which one open, which one you know, under payment. But so far we don't have in our consortium any guys, any company devoted to the cloud, for example, registering. So for this, we are going to subcontract to others because we don't have. For what is the design, I think that we deliver a solution for the designer. So for you, so yeah, I don't think it's the market strategy is not like this. Our market strategy will be a different one. Supporting and providing solution that could be taken from others to, you know, to be implemented. This is mainly so far the idea, but everything could be changed. It depends from the validation, the results.
Mm-hmm. Thank you.
Thank you to you.
Okay, so Michele, would you like to carry on for the closure?
Yeah, I think there is another person, the C, has switched on the micro. I see the C at the end. If you, yeah,
yes, if I may,
yeah.
just quickly, just to precise on a very important question just discussed now, and to precise the passive house limit for heat demand is indeed 15 kilowatt-hour per square meter per year, and it's a very interesting reference, and that it's oftentimes there is some clear benchmark, and it's not the case when we speak of zero energy buildings, as in the title of your project, because there is not a unique definition of zero energy building. So this is a good to be addressed up front, so it is clear for the lecture, for the reading of the results and if I may, if I'm not taking too much time for the discussion, I will just ask a small technical question. For the system, it is foreseen for functioning with individual ventilation system for the apartments in the case of a residential building, or collective buildings, or can it be used in both cases?
I can answer this question. It depends. We have evaluated different solutions, and centralized solution is something that we can manage in the cavity of the RenoZEB overall facade system, but eventually we can manage also ventilation inside the monoblock, so working specifically for each space, internal space. For what concerns HVAC system, the solution are also in that case or centralized, and that are one of the possibility. The other chance is not being evaluated, but it's possible to install something on board on the data itself and to provide the energy needed inside to the indoor space.
Okay, I don't know if there are any other comments. We have a few minutes, so it's okay. Don't consider that you are stealing time, or we are on time. So any comment, any suggestion, any thought you would share with us, it is welcome. Meanwhile, for me, I would like to repeat myself for what I said in the very beginning. Thank you very much for being here, for believing in us. We have done a tremendous job so far, from what is related to the hardware part and also for the software. We still are in progress with other tools and for honing and shaping and putting all together for the validation. As you know, we're right now in the critical point of the project because of the COVID delay and the emergency we have experimented so far. We had the delay also in the retrofitting, so we have to catch up with the time. Maybe we are not going to use 12 months, 1 year of validation as expected, because we are a bit in delay, but we have also contingency plan to cope with this. And meanwhile, again, yes, this project delivered TRL7 solution, but again, you are there. These tools are free to use. Have a look at them. Of course, maybe they could be improved, or they have a strong point that could be used by you. So have a look. If you can use in your daily job, you can also test in real, for real. Any comment, you can get back to us. If you see that this solution could be actually very useful for you, just let us know. Something that we can improve for the exploitability and the marketability, that's also welcome for you. For us, consider that we would like to really solve a problem, help and support what is the gradually improving of this retrofitting process, and getting to the software and getting to the technology helping the process. So we believe in this, and if you have time, test them in your real life, and let us know. And maybe the day of tomorrow, we could have also something after this project. The project will end in August 2021, but at the end of the project, we can also create something, and this something could go to the market. We're expecting that, and because the solution could be really practical and pragmatic, so real solution. So if you can test them, you can do that, and tell us something, and you can spread the word also as a trainer to others. And if you do that, if you need our presence, my presence during your activity of training, please get in contact with me. I will be very honored to do the introduction or whatever you need. And yes, I think this is the final message. I know that there are a lot of information to be digested. Sit down, take your time, and once you have this done and you want to talk with us, we are very happy to listen. Thank you very much, all. So if there is no comment and you agree, I will say that this session is officially closed. And again, thank you very much to everybody to be here and to listen to us. Thank you very much.
Thank you too.
Bye bye.
Okay, thank you to everyone.
Bye bye.
Bye bye.